we're up on YouTube. Come on, come through. There we go. Okay, hey everyone. Zach, congrats on the first. Metallica, hey. Pyro, hello. And Slim, thank you very much for the raid. Welcome in everyone. Benvox, hello. This is the general relativity reading group that happens on Saturdays for about 2 hours, and then I do math. Before we get into it, though, I changed around the tech for the stream a little bit. I want to... Okay. That up there is an honest to goodness YouTube chat. So I got that working now. Storm, I have not... I ended up not even trying the actual problem yet. I still want to do that at some point. We're not going to do it right now, though. I might need to turn the YouTube chat back off if people are degens over there too much, but at least we'll see how it goes. Hey, Pyro. But yeah, I'll do this one at some point. I just had that on screen to hide what was on my browser while I made sure things were working. It's going good. Thanks for asking. I think we're set to go. I'm gonna hop in Discord with Fembox. Hello, hello.
Hey.
How's it going?
I'm doing about as well as I could be expected.
Yeah. Yep. Okay, so I looked last time we ended off on number 4. Shoot, I should have brought up the actual images I have. Where are they? Okay, next one I have marked as number 5. Oh yeah, and I think this one is going to be a good one for us to try, because I remember we had a question about this last time we talked. And then hopefully we'll find the Excalibur. Make sure I posted the link. Okay, yeah, I did.
Cool.
Okay. Hey, Rex. I don't remember doing that. All right, so we got figure 5.6 drawn at the acceleration for vectors A at half scale. Are these vectors orthogonal to U? I thought I thought they showed, like, if f dot u is 0, surely f dot a is 0. Okay, yeah, u dot a is 0, I see on page 86.
Yeah.
Right after equation 5.38. So these must all be orthogonal.
So what's the definition of orthogonality in for 4
Oh,
vectors? Is it just dot product is 0?
I didn't think about that. I just wanted to draw a right angle and not worry about it, but you probably should. We do have to worry about that. Yeah, if they dot to 0. What does that mean? Um,
Well, we have the components of acceleration, right? From example 5.5.
ooh.
at the bottom of that same page, 86.
Oh, you're right. That's a great thing to use.
And we have components of velocity from the page before.
Okay. I forgot that we had these. I thought we would just have to kind of guess like how this would look, but this is an improvement. So I guess we can maybe test out the dot thing first off.
Okay.
A dot U. So it's a minus and then the time components. A cinch A tau. Cosh. What? Oh, that Cosh. A tau. Plus a okay, yeah, this is gonna zero out.
I meant to try and put Discord on my iPad. I keep meaning to do that, and I didn't do it yet.
Oh.
I got to see if it works well. It probably would.
Yeah, I think that's how Penn Center would do it. Or it's he had something weird like that.
Oh, okay.
But yeah, there should be a way to make that work.
So this is just zero then.
Yeah. So that's presumably good news. I'm thinking about that the hyperbolic like a dot b is minus ab cosh theta. I don't know.
Oh, that's question 2 that you were working on the other day.
Yeah, that we never actually did it, but is cosh ever zero? That's
No,
I don't think so either.
I don't. I don't think so.
No, it's not.
I think it's even and it goes through 1. I think 0, 1.
But the magnitude of the velocity and acceleration isn't zero either. So I don't know how that. Oh, these aren't time-like. No, they should be time-like. Maybe they're not time-like. And we shouldn't use this equation. I thought it would be time-like though.
Yeah, well, they said this was a time-like particle, didn't they? This whole example? I thought.
When they first introduced an example 5.3, I don't see the word time-like anywhere here.
No, I was just looking for it as well.
I wonder if there's a way we could. Well, I guess we know how to check. We would do we would dot it. We would dot something with itself. I don't know if we want to do position or velocity though. Well, I guess velocity is always the -1. But I mean, it doesn't seem like that. It seems like from that dot product thing that it probably isn't time-like.
Really?
Or like the dot product thing doesn't seem to be true, so I would assume it's not.
Figure 5.7 says something about. Okay, what does it say? The forward velocity at any point along a particle's world line is the unit time-like tangent 4 vector at that point. It lies inside the light cone of that point.
Right.
So,
I guess, yeah, that is for like a regular particle that's not, that, you know, it's not going faster than the speed of light. And what's the Pythagorean hyperbolic thing?
Cosh squared minus shine squared equals 1.
Okay. And so this is,
Oh, by the way, do you call it shine or do you call it cinch?
I was taught cinch. I never heard shine aside
Okay.
from you, or like from you.
Okay, I'll try and remember cinch.
I don't mind
If I
either
say
way.
shine, you know what I'm talking about,
Yeah.
right? Maybe shine sounds too much like sign, right? Cinch is probably better.
I think no matter what, it's kind of dumb.
Yeah, it just saves a little bit of time because, instead of having to keep saying hyperbolic all the time, it's
Yeah.
I've been thinking
I don't
about
think there's a good one.
yeah.
But if I do x dot x, I get a to the negative 2, which I guess is a positive number, which would mean space-like. It's probably not all that.
Hmm.
I don't know if it's all that important for the actual question. This is just in connection to like the minus AB cosh theta thing.
Well now wait a sec. That X you just dotted with itself was just a component, wasn't it? I don't think that was a vector. Does
Uh,
that make a difference?
I use the position for vector from that one example. The same example, or the for the same like A and U that we were just looking at, I used the position for that and I dot it with itself.
Oh yeah, sorry. Yeah, I'm with you there. So you're saying the X vector was like the time component and then the X component and then two zeros, I guess.
Yeah,
But
I
you're
didn't
thinking of it
draw
as
those in.
yeah.
Um, like I kind of want to just do the simple thing and draw in acceleration vectors that are probably decreasing, or they start big, decrease towards the middle, and then start
Yeah.
increasing again.
Yeah, I mean, I see what you're saying there. Okay, maybe what we can do is we can find out what tau is, right? What did they say? Tau's going by 0.5s. So I think this is like,
Oh, did I get a bad screenshot? Should there actually be grid lines? I mean,
no, I don't think, no, there were no grid
okay.
lines, but the dots, like it
Oh,
says
you're
tau
right.
equals,
Yeah, they do say that there. Yeah, I guess we could actually
yeah.
calculate this.
Oh,
Oh no.
what do I do? Alt Z? Control
Control
Z.
Z.
I wrote on it and now I don't know how to erase it.
Uh,
Oh, I just got to Control Z again. Here we go.
oh yeah.
There we go. So let me draw it over here. So we have something like this. This is tau equals 0. And then like 0.5 and 1 and negative 0.5 and negative 1. I think that's how it works.
Yeah, yeah.
So can we just, maybe we could just plug in those numbers and see what we get for acceleration and for velocity. Maybe that'll make sense. I don't think I tried that yet.
Yeah, I think we could. Um, so a, I guess maybe 0 will be the most instructive. I don't know my caution cinch is the issue. Cosh cinch. Okay, cosh of zeros. Oh, that matches with sine and cosine. Okay. So the time component is cinch. So it's 0 a, because cosh of 0 is 1. And then just to check, our u of 0 is 1, 0. And so 1, 0 matches up with that u there. Phobos.
Hey, Phobos.
Thank you for the raid. Good job on the code roast. I couldn't see all of it, but I hope the rest of it went well. For anyone who's just joining us, Penbox and I are talking about general. I mean, this is a reading group that's building up to general relativity. We're currently learning about special relativity on the way to that. And hey, Aziz. So yeah, we're working on this problem here.
We're learning here. We're
Yeah.
learning about special relativity.
Yeah, so we're doing stuff with 4 vectors. We've got some non-Euclidean, I guess like it's like hyperbolic space or something. But it's good. Chody Banks returned, looking pretty good. Very Chody. Nice. So I think this is a good thing. We did get a perpendicular vector, at least for the 0 case. It's length a, which I don't know if that should be big or small, but is it more or less than 1?
It does say in the text here that, what does it say? 4 velocity vectors are shown for these points at half size. How does that mean he just drew the arrows half as long as they're supposed to be?
There's not really a scale for time.
I know there's no real scale. I mean, the only thing we have on the picture is A inverse, and who knows what A is. So,
Oh, yeah.
okay, let's. So should we try like tau equals 1 maybe and see what we get?
Sure. I want to make some room.
Oh.
Okay, so
Or these are. Oh, you know what? Wait a second now. These are A. Oh, these are A tau. No, these aren't tau. These are A tau. Each one. Okay. What I got here. I think that's what
are
it says.
they?
I think that's what it says there. Yeah.
That's. Oh yeah, I do see that A
The
tau
points label
there.
values of A tau. Yeah. Well, that's good. That's makes it simpler, I guess.
I guess I'm confused by their axis labeling then. But, and also how we, well, if A tau equals 1, then what does that, like, what to do with the A's out in front? Oh wait, yeah, you're right. They do say A tau right over there. I assume that would just stay in A then. I don't really know what to do with that.
I think that would just stay in A because I think we're only worried about it for the input to the hyperbolic functions.
Okay. Are sinh and cosh of 1 anything special?
I don't know. 1/2
Um,
of E plus 1 over E, something like that.
Aziz, I'm not sure I understand your question there. And hey, Shrikant. It's just kind of a number. I wonder if it's better to leave it as sinh of 1. Probably is. So acceleration is A sinh 1. I guess A cosh 1. And then U of 1. It's cosh 1. Presumably, like, the cosh and sinh being switched between each component is going to assure orthogonality in some way. I just have a very hard time actually picturing it.
It's weird without a negative sign, isn't it? But I think you're right. I think you're right. I think they should look orthogonal on our picture.
Um, ooh. Which way is this thing
Actually, is that
accelerating? It's scaled by A.
do you think it will be? Do you think it will look orthogonal? Hmm.
Uh, it doesn't seem like it.
Because we
I'm,
don't have the negative sign that we need,
yeah,
right?
I feel like it's something like that. Smaller than you. I mean, yeah,
Oh, wait a second now. Wait a second now. You know what? I think the directions are um symmetric with respect to the 45 degree line. So the first one we did at 0, we had velocity going north and acceleration going east. I think for any point, like the angle, the velocity and acceleration directions should be reflections in the line y equals x, right? Or in a line at 45 degrees. Maybe. I don't know if that's true.
oh, because we're switching cosh and sinh.
Yeah.
Uh,
Did it make sense? It made sense what I said, right? So
I
I'm
could
thinking you
see
got some
that
line of,
happening. I'm trying to figure out why.
so we got some u vector like this, and I'm thinking the acceleration vector might be like there, where these two angles are the same, if this is 45.
Okay. Yeah, and we know that the kind of hyperbola that forms the position like is going along the line y equals x in the long run. I mean, it's kind of a little bit below it, but we could like at that tangent point, I guess. Um,
So as proper time goes to like infinity, then the acceleration and velocity would both be going the same direction. I don't know, it could be right.
ooh, Maybe. That, uh,
Here they also said, draw your acceleration 4 vectors at half scale.
yeah, and the A
So
in
I
front
hope
kind of
we're,
throws a wrench in the gears, but
yeah.
your argument does feel a little bit odd at A tau equals 0. Or I don't know how to apply your argument there.
Well, they'd still be reflections in that line, right? So,
But it's not at an
yeah.
angle though, right? In this one?
Well, I mean, so let's say this was the
Actually,
point, then that would be going straight up and this would be going straight over.
yeah, I guess that's what I would expect the acceleration vector to look like, yeah.
And what about if we picked a point like down, like this point down here, right? Like, or like one further down on the bottom side, what would that look like? So here, what would this, let's say I drew this. Oh, well, that's weird. Well, that means yeah, the acceleration would be something like that there. I mean, it could be, right? It should be slowing down there, maybe.
The arrows do physically go from big to small, then back to big.
I gotta not write on this.
It could be like like the reflection, I guess, yeah. With that, maybe we need to plug in a number and just see what we get for -1.
Okay, yeah, let's try that.
Hey, one tap. I don't know, apparently you like nerdy stuff, or YouTube thinks you like it. Cinch is odd, so it's going to be minus a cinch 1. Then cosh is even, so it'll be a cosh 1. And then it'll be cosh 1 minus cinch 1. So it's pointing in the positive time in the negative x direction. That's good for the velocity. So the numbers agree with the pictures. And then acceleration is pointing negative time, positive x. So I think you're right. It's that same kind of reflection, or it's that same idea with the angle being the same, but you reflect it across that normal line.
It's all that reading I did in that book that was just hammering space-time diagrams the whole time. So now I just want to think about space-time diagrams.
I wonder if this has something to do, or I feel like there's like um, the fact that they have to dot to 0 feels like it forces the angles to add up to some like 45-degree angle, because that's like the null line. I feel like there's something like that that's happening here. But I have a hard time putting words to that idea.
Can you say that again? You said something about the 45 degrees.
It feels like there's something, or like it feels like the 45 degree like angle line is a special one, because that's where you go from like time like to space like,
Oh yeah.
And if a dot u is 0, I feel like that means they have to dot, or in some sense, the angle should add to a null like line or something like that. I'm not entirely sure about that exact phrasing, but yeah.
Oh, wait a second. Also, yeah, what about this? That hyperbola we started with, right? It's
Mhm.
like a rightward facing branch of a hyperbola. And so how about this? How about this? The velocity vectors are tangent to that, right? Maybe the acceleration vectors are tangent to a hyperbola that's like north, like upwards opening. So
To
what
the
I'm thinking is that
velocity
like,
hyperbola. Maybe?
yeah,
Okay.
hmm.
If
Because
hmm.
we've got the hyperbola, what do we got? Like y squared minus x squared equals 1. Is that what this is? But then we could have x squared minus y squared equals 1.
Yeah, I assume that's what we're doing when we take the derivative and they switch around.
Hmm. Oh.
It's 100, 100. I'm just going to Desmos quickly and doing this parametric, like switching thing just to
Yeah,
test it.
looks nice.
Okay, yeah. If you switch the x and y components, you do basically take the inverse. Um, it's weird because the scaling is going to be different.
Yeah, but so now let's say so they both have the same parameter of t, right? So what I'm thinking is, let's see, can you, on Desmos, can you animate that? Well, let's see, how would we do that? Can we put a point on both of them that kind of like slides along as t varies?
Um, maybe I can make them functions.
Oh,
Two. That does make a point for us. Oh, why does it get rid of them now?
maybe you can just make a slider for t.
Uh, I need to make it some other letter, I think. I don't remember what we're trying to do now, though.
Let's, okay. Yeah, this is what I wanted to see. Yeah, so they go off towards infinity in the same direction, right? Yeah, here we go. There you go. So so one of those is showing us the velocity, our velocity, and the second one showing us our acceleration. I think at any instant.
Yeah, I think. Gosh, purple is velocity. Hey, Fizzbuzz, they're a cinch. They
And he
sure
said
are.
cinch. Look at that. He said cinch. Fizzbuzz. We were just having that discussion. Is it supposed to be cinch or shine? I think I'm the only one who says shine. It's not my fault. I swear to God, I didn't make it up. Somebody told me shine once upon a time.
I believe you.
So, and let's see, what else do we need?
Um,
In the problem they gave us, the magnitude of the acceleration was a, and the magnitude of the velocity was 1. So I guess we'd have to, so let's just say the acceleration is 1. But you know what, Don, what I'm imagining, I'm not imagining it's two different I'm sort of imagining, what am I trying to imagine? I'm imagining that the hyperbola at the top, as you let t increase, the change in that little dot that's riding the top hyperbola is telling us the instantaneous acceleration of the point on the bottom hyperbola, right?
Uh,
That's how I'm trying to think of it.
Gosh. Blue is velocity. Um, or the top one is acceleration.
Yeah, so right, the point you've got it on the screen right now, right? If you imagine the clock running forwards a little bit as tau increases, the acceleration is sort of, I don't know if this is the acceleration. It's moving right, yeah, and the one on the bottom hyperbola is moving up. So I feel like these things are always. Is it the average of their angles? I feel like the average of their angles is always 45 degrees.
Yeah, because like right at like the 0 point, you have a 90-degree angle and a 0-degree angle.
Yeah.
Yeah, I don't mind that. It has to do with that same like reflection idea that you've been talking about across y
Yeah.
equals x. There must be something more here.
Yeah, for sure.
There's got to be a good like interpretation here. Rostislav, that's the goal. Right now we're on special relativity. Naman Fundamentals of Physics book by Halliday. I have not read that.
Oh, hi, famished. I'm person.
Yeah, I figured out how to get in the Discord icons in the upper left, so you can actually see that Funbox is there now. I don't know how readable it is.
Oh
Schools,
wow, yeah. There's me.
yeah, up the day. I think I remember that. In Hey Central, you got a Clip is doing Twitch is doing a clip badge now. Hmm. Okay.
Halliday and Resnick. I've got that book.
Oh, nice. Yeah, if you've been here on a Saturday, you probably have heard his voice. You just didn't know it. Um, okay, I don't know how we can possibly draw this to half scale because we don't know what A is, but I
Well, if the vectors they gave us were at half scale, then we just have to kind of model our scale off their scale, I guess. Like keep it in the same proportion.
uh even then I don't know how to do that because the U is
You
just
don't know what A
scaled
is.
differently than A.
Yeah, yeah. Well, let's just pick an A. We'll pick some
Yeah.
A and we'll just go with it.
I think that the big thing here is that A starts big, gets small, and then gets big again. Um
You're saying the acceleration?
yeah.
Yeah. Yeah, that sounds right.
It is kind of accelerating off to infinity.
I'm not a teacher famished. I'm a tutor. Similar, I guess.
Yeah.
I think being a tutor is
Naman,
better because
yeah,
I always
it's
thought
more
tutoring is
fun.
better because I don't have to grade papers.
Yeah. And you get to criticize the teachers for teaching things weird. You don't have to actually take responsibility for teaching something yourself.
Yeah, exactly. You know what I always say? I don't know if I've already said this on your stream before, Don, but the difference between teaching and tutoring is like being a parent versus being a grandparent, right? If you're a parent, the kids are like your responsibility the whole time, right? But when you're a grandparent, you just get to have fun with them when they show up, and then they go, and they're not your problem anymore.
Yeah,
So
that's a really good metaphor. Yeah.
yeah, it's wonderful. It's a great job.
Numan, I took two physics classes as an undergrad, and I've done some like self studying too. I didn't go straight to relativity. Yep, Hamish, it can be a really good gig.
Yeah, it's great. It's a great way to learn it yourself too. You know, when you help other people, it really helps to learn it yourself.
Yeah. All right, should we check the solution on this?
Yes.
All right, 5.
Oh man, we're on fire. Look at that.
Yeah, it's looking pretty good. They're about the same length, which I assume they just kind of chose that. Solutions are orthogonal to the four velocities in the geometry of space-time. They're orthogonal in space-time, but not in Euclidean geometry of the page. Okay, good.
So okay, so the dot product was 0. We were right about that. But yeah, when we draw it on our picture, it doesn't look orthogonal as we look at it. Hmm.
Yeah, what it means to be orthogonal, I don't know what it really means to be orthogonal in space-time visually, but I feel like we've come up with a nice thing for like this weird Euclidean representation of it with something should add up to 45 or average out to 45. For reasons that still aren't completely clear, but
Yeah.
okay.
All right. That was pretty satisfying.
Yeah, strong start. Number 6 is the next one I have. Product moving along the x-axis as a function of time. Oh man, I really need to. Oh, of time is this, where g is a constant. Does this particle speed ever exceed the speed of light? Um, I assume we maybe want to try a limit here as t goes to infinity. It's going to approach
Okay.
1. Is doing it from above or below? Probably below.
Yeah, because the denominator is always a little bigger, isn't it? Because of that
Should,
+1.
yeah. Does negative time? No, I guess it would be a sigmoid function maybe? Is what I'm imagining. Almost like arctan. I'm just like worrying about the negative time also. But I think it's something arctan-ish.
I don't know.
I guess it'd be approaching. No, it'd be approaching 1. These would be 1 and -1.
Yeah.
And I'm not doing this in the space-time convention. Silly me.
Oh, right. You got to reflect it. So now we got vertical asymptotes.
Well, it's his velocity that I'm drawing, isn't it? Uh, this is +1. That's -1. And so this is speed. We're always inside of the 1, -1 bound. So I think no. Oh, like photomath? Yeah, I think I've heard of that. I mean, I guess we could also just do limit at least out to positive infinity. But because we're working in c equals 1 units, I think 1 itself is the speed of light. So as long as we're less than 1, we're okay.
Yeah.
I'm not very enthusiastic. I'm just gonna say it's 1. I don't want to actually prove it. I just know it's 1.
Yeah, it's just one, right?
Yeah. Okay. I guess that's maybe good enough for A. Calculate the components of the particles for velocity. We have to parameterize this in tau? Is maybe the task here?
Oh, yeah. Isn't that how they did it in that other example? Example 5.3, the one we were just looking at, isn't that how they did it? They picked a parameter, sigma. Yeah, this is kind of like that business of arc length parameterization.
Yeah. This but now we're starting from speed as well, so we presumably need to integrate this at some point.
Okay.
Oh wait. No, sorry, for velocity. We don't need to integrate it. Do we we can oh no, we have equation 5.28, the 4 velocity in terms of the 3 velocity. Well, we still want proper time. How does this work? Oh, we do the chain rule thing. So the x component of u is d something
dx d tau.
dx d tau, which is dx dt dt d tau. And we know what dx dt is already.
Yep.
dt d tau. Now that's gamma, except the velocity is varying.
Ah,
Um, oh no, maybe it's okay. Maybe dt, or I forget why, but dt d tau is just gamma, and it's okay if it's a function? Are we going to get a function in t and not tau, though?
yeah, I'm used to gamma being a constant.
Yeah. The acceleration, though, I think that just doesn't happen. I remember it came up in the last meeting, too. Like, we had a variable gamma.
Yeah, I remember that too. Maybe they only use the letter gamma when it is constant. Maybe if it's not constant, they stay away from that, just calling it gamma.
Maybe, yeah.
Well,
Oops.
okay, but what is it? It's 1 over the square root of 1 minus v squared, right? So would we have to put 1 over the square root of 1 minus
That's what I'm
that whole
trying.
thing
It's not
squared?
it's not gonna be pretty, but yeah, I guess.
Oh yeah, I just said that and you're already halfway through doing it.
Anders, yeah. Hey Matthew.
Yeah, Anders, it's Lorentz transformations.
Um I still don't I mean I guess we can maybe once we get each of the components we can then convert it to be in tau, not t. I I'll show the original problem here for a second, in case you want to screenshot or something, but the math is down there, so I'm going to scroll back to it. But yeah, we have the velocity of a particle, and we're trying to find the components of the 4 velocity. Selvamani is asking, how should we physically interpret 4 velocity? Is it just a mathematical tool, or does it have a direct observable meaning? It's a good question. We can observe the effects of it for sure. I don't know that we can actually visualize it though. I'm not nearly experienced enough with this to be able to confidently give you any sort of answer though, I think. If we get a common denominator here, we
Oh
just
yeah, this
get,
simplifies nicely, doesn't it?
yeah.
Okay.
Okay, yeah, I think that's
Oh, look
right.
at that. Look at that. So you flip it over and multiply it by v, and we just get gt, don't we?
Wait, do we? The 1 plus still messes it
I
up.
think so.
Yeah,
Well, I mean,
Papadoria.
I'm saying when you bring this and multiply it by this now, isn't that what we got to do
Oh,
next?
yeah. Um, you're right.
Oh no, you lost half your gamma.
I did. Oh, I did. What I get for being lazy with dragging things over. So we get just GT. Well, that's nice and clean. Matthew says, in terms of differential geometry, 4 velocity represents at the same time the velocity and curvature of the space-time you're at.
Nice.
Okay. Oh, Papadori, before I forget, I don't remember if I told you about his stream before, but Academy of Useless Ideas was talking about your Fibonacci problem, and he streams on YouTube as well. I just wanted to quickly grab that for you. I should have had the link ready. Sorry, Fembox. I just want to.
Yeah, yeah. No, take your time.
I he was trying to do it with right triangles, and I didn't catch if he actually found a different way of solving it. But you might be interested in his stream in general too. So I just wanted to like share that. He knew the problem because we just know each other. I assume he saw me doing it or someone brought it up to him. But yeah, he actually just rated me on Twitch a little while ago. Yeah. Um, Tangent space and cotangent space info at the same time. Ooh. yeah, if you do get a chance to check him out live, uh, I'm sure he found your problems pretty interesting too. Okay, so we have I think this
And
is
maybe
what,
the gamma you just worked out is our time component, is it? Is that
yeah,
what you were about to
so
say?
I think
Yeah, okay.
we have it in T. We want it in tau, but we got the first part of the problem done.
Oh yeah, how do we get it to tau now?
I think we're gonna have to use they use d tau squared equals dt squared minus dx squared.
So they did.
Um, what happens? Okay, I guess let's just start calculating things. D tau squared is the derivative of that squared. Wait, no, in this example, they're doing with position.
Yeah, yeah,
Do we need derivatives
yeah.
then, or do we maybe just take it at face value?
Or do we need to integrate like you said earlier?
Oh, that's possible too. Oh, we could check as a little check. Oh no, we need to in tau for it to be normalized, probably. Um, it'll be annoying if we can't just directly. Maybe we do need in position. It I would like to just keep everything in velocity, not worry about integrating. Um, can we say?
What have I
Can we
done?
do a physics thing? I guess this wasn't you. This would be. Could we just say that u is the same as dx dt and multiply the dt to the other side? Oh wait, but this.
I don't know. I don't think so.
Jesse, been busy marking and witnessing novel maths. Ooh, is that sounds like actually an insult now that I think about it. The minus to the plus sign, that's something, Mudvayne. Ah, there must be a way of doing this.
Yeah, this looks good.
Sorry. What? Which part looks good?
I'm just thinking about integrating dx dt to find x. I think I got it right. I did it up the top here.
Okay.
I think it checks out. You can see it makes sense. Because if we did what, chain rule, let's see. Yeah, I had to get a G down here because I think is that right? Yeah, because we wanted that one G to be left.
Um, you're you integrated the original thing there?
Yeah.
Would it be better to integrate the 4 vector? Or because would we have to convert this to a 4
Yeah.
vector from here now? Or actually, maybe this already is a 4 vector. It's just going to be, I don't know.
If you compare that thing I got there with what you got at the bottom, right, for the velocity vector,
Yeah.
it feels like it makes sense. It feels like those two things are telling us the same thing somehow. Because if I multiplied the G over here, what would I get? I would get G times X is this square root of 1 plus G squared T squared. No, I don't know.
Um,
I don't know. I don't think I get it.
you know what? I think they took the position and they took the derivative of each of the components anyway. Maybe we already have the derivative. The more I look at it. Because in example 5.3, their dt squared involves cosh, but just t of sigma was sinh. So I think they did take the derivative.
Yeah.
So maybe we just use the 4 vector components at face value. I had Jess, isn't that called like the freshman's dream or something? That like simplification. 1 plus g squared t squared dt squared plus g squared t squared dt squared. Hey, Adia. G squared t squared dt squared. What do we do with that? I'm doing good. How about you?
I guess you take the square root.
Oh, we integrate it? Yeah, we square
Oh, is that
rooted
what
and
it is?
integrate it. I I know Jasu. I like that freshman's dream thing's a joke about that. Um, yeah, I think we square root and integrate though. That's gonna be a job for Wolfram Alpha. Because we need. It's probably a trig sub. Um, they probably read an integral table somewhere in the book too, but squared dt. Wait, we have a 2. No, not inside A. No. 2. Oh, that's disgusting. Hmm. So many people did that, Jasu? Oh no. Was that your quantum chemistry class? Or like, was the super advanced one where people should probably know better? How annoying. Oh wait, I forgot a minus sign.
Did you?
Yeah, because d tau is dt squared minus dx squared, minus all the other space components.
Oh, well, that's
That makes it so
kind of
much
cheating.
easier. Yeah. So we just get they're equal to each other.
E equals
It
tau.
already is proper
Well,
time.
that kind of makes sense because I mean they gave us a x as a function of time basically, didn't they? I mean, it feels like these guys are we could just let t equal tau in the original thing they gave us, it felt like.
Maybe I don't know what to trust anymore though.
Yeah.
It is that simple. Okay. The thing that we could check is u dot u should be -1.
It works. I can see it works.
Uh oh yeah, because the time component gets the negative.
Yeah.
Plus. Okay, nice. -1. Okay, so that's a good sign. The 6 years. Oh, nice, Lucas. If you want, we can try it after. If you have a question about it, it's gonna be about an hour though. That's fine if it's in Dutch. Okay, express x and t as a function of proper time along the trajectory. I think we can just integrate. And I hope there's nothing more complicated than that to it. Okay, so part C. Oh, well, this stupid thing. Now I really do have to integrate it. Well, there's no 2 now. I don't think it makes it any cleaner though.
So how do you integrate a 4 vector? Do you just integrate like component wise?
That's what I'm assuming, yeah. Is there a hyperbolic sub you can do here? Is that what they really want? Do they give us a table of integrals?
I think we kind of I think we kind of have it from what they gave us at the start. Because if we just let t equal tau, what's the question say? Express x and t as a function of proper time. Do we have to pick like do we have to fix a starting point, like a plus c kind of thing? Can we assume that it starts at the origin at time 0?
Yeah, they do that in the example too.
Okay. So what about if we just say t equals tau?
That'll make life a lot easier. I'm willing to go with that.
Does it make sense? So this means So what was that first graph you drew? That's the velocity, right? So, okay, so it's negative and then it becomes 0 and then it becomes positive. Okay, so yeah, so we should have a particle that's moving left and then it stops and then it moves right. Okay. And that looks like what this x of tau is telling us. Like the minimum it could be would be, oh wait, what would the minimum be here? Radical 1 over g. I could put a, I could put a -1 up here to make it hit the origin. Why would I do that?
I don't know. I would need to put this in decimals. I don't know how it looks for small values of tau. 6 square root 1 plus x squared. Oh, it's like a hyperbola. Well, these things always just come back to haunt us. Okay. Junior, I wish I could.
That's the goal. We're trying to understand all of relativity. So do you think that's all right for part C?
uh, I guess I wish
How does
that
how does that
the
how does that make sense
integral.
with what?
Yeah, I wish that the integral of the u agreed with that. Um, yeah, Lucas.
So let me write something here. So this could be, if you use what we had up there. This is g times x of tau.
Would we need to divide a gamma or something? Is that the key? I don't think so.
And g times t of tau. Why does that seem backwards? I feel like the x is where the t should be and the t is where the x should be. Oh no, wait, this is velocity. Yeah, maybe it's right.
I don't know. I think. Yeah, I just don't know. uh, there's a bunch of lectures on YouTube. We're just reading out of a book right now, though. Looks like pi with only one leg. Oh, tau? Yeah, basically it. I know. I don't quite get how the answer or how you get it from the four velocity, but the way that you did it from dxdt looks okay. For part D, they want the 4 force and the 3 force.
Hmm.
Well, we could get the 3 force just using normal Newtonian ways, right? Like we can just take the derivative, multiply m.
Yeah.
Okay. And I know there's a formula for 4 force in terms of 3 force. Uh, Quotient rule. Low D high. Okay. Root 1 plus G squared T squared. D high is just G minus high D low. 1 over root 1 plus G squared T squared 2GT. G squared T.
Maybe you don't need that 2.
Yeah, it'll cancel. Oh, I might have forgot. I forgot to write the 2 down there. I had it there mentally. Okay. If I do a dangerous thing and try to get a common denominator in my head and simplify this. G cubed T squared. We're going to get a cancellation in the numerator.
Nice.
I'm just verifying my work quickly before actually doing it.
Yeah, it looks. I think it looks good.
Okay. So then,
There's still a G on top. Oh,
is there? Oh, you're right. Yeah.
yeah.
I didn't distribute the G properly. Okay, so 3 vector F is mg over 1 plus G squared T squared to the 3 over 2. 0, 0. They said the 3 vectors, so I'm just being paranoid and writing out all 3 components. Okay, and then what's our formula for 4 vector?
Oh, yeah. Good question. Page 88.
Oh, gamma F dot V, comma gamma F.
Yeah, we talked about this last time. This is where I had lost my mind in this chapter.
Yeah.
I looked at
I'm
this a
not sure
few
what that
times,
means.
but I never understood where it came from.
Yeah. This is 3
Here's an
vector.
example where we have gamma and V, don't we? Yeah. Okay, so they can't be the same, can they? I want to say gamma is a constant and V is not a constant.
I think gamma is still a function.
Is it?
I think gamma is the same thing it's been the entire problem.
Just 1 over root 1 minus V squared.
I don't see why it wouldn't be.
Yeah, okay. Yep. I'll buy that.
Okay. So they use small f, right? Yeah. So gamma was root 1 plus G squared T squared. And then f dot v, we only have x components here. So we're just taking the thing we got for f, multiplying it by the thing in the original problem, the dx dt. So times mg over this g squared t squared, the 3 over 2 times we can, maybe I should be using tau in 4 vector land. gt over root 1 plus comma gamma f. Yeah, Jasku, that's YouTube for you. I can just do that cancellation for gamma f. It'll be 1 plus g squared tau squared 0, 0. Okay, cleaning this up. M g squared tau over 1 plus g squared tau squared, so 3 over 2, comma. You can do that. Yeah, so yeah, and you like bump their chats up too. Okay, does this seem believable?
I have no idea.
Me neither. Are we expecting certain units? Um,
Oh yeah, that's a good idea. Let's think about units, right?
the time component is power, energy per time. Eldritch. Let Eldritch have a good day. Well, I hope it is a good day for you. What is that? kg meter squared. Do we have double time, or what's the unit of proper time? It's distance. I feel like proper time is measured in meters.
Yeah. Yeah.
Oh wait, we're in c equals 1 land.
Yeah, C equals 1.
Gravity is acceleration is
That's what I'm wondering. What's G? They just said it's a constant. Can we go back to the original thing they gave us and work out what the units would have to be? That's what I'm trying to do right
I
now.
think it's inverse meters. Because distance is measured in meters. Velocity is meters per meter, which is now unitless. And so acceleration is inverse meters, I think.
Oh, velocity is meters per meter.
Annoyingly.
Because we let C equal 1. So velocities are dimensionless now.
Yeah.
So tell me again, so G, you said is 1 inverse meters? Inverse
Yeah.
meters. Oh, okay. Okay, I get it. So then G times T is also dimensionless.
And that's
So that
good.
whole thing they gave us is dimensionless. Oh, all right.
Well, I
So
or
then N
maybe the
times
original
G
thing.
is a 4. That makes sense.
So we get
M times G is 4s.
okay, yeah. This is kg over m would be a force. But I was expecting power for that. See, Eldritch? Any left some of your coins so I can give you that? Hey, Sandculp. What do we get for units for the regular
Maybe we
force?
should check all our units.
mg kg. No, that okay. Yeah, I think it checks out for the 3 force.
Yeah. All right. Let's ship it.
Ship it? All right.
I don't know. What do you think?
Yeah, no, I don't see what else to do. This is the question here, Sankov. We're about to check the answer though. Matthew, yeah, that's Fembox.
Matthew, hey, how you doing? This is you're listening to the mellifluous tones of Fembox right now.
All right, A we got right. It's less than 1. Rez. It was good to play Reaper with you. Hope you've been well.
Yeah, you got the second part right. That's right.
Oh yeah, we did do that right. Holy crap!
Now we changed the T's to tau's, but I guess that doesn't really matter.
Yeah, they're equal, I guess. So far it's going surprisingly well. Usually, Lux and I are kind of are just confused when we try and do these problems, but so far it's been going well.
All right, I think my idea on part C maybe didn't pan out.
Oh, yeah. What the hell
It's
is
like they did
this?
say root 1 plus gt squared over g. I did come up with that. I didn't get a hyperbolic sign anywhere though. Maybe it's
Oh,
just a
they
different way
showed
to
this
do it.
formula somewhere
Yeah, that was in the other chapter.
in 4.
Yeah.
Okay. And Don, you can say slightly sexual stuff, Doria. I don't care. Femdon. It's funny. Hey, Rez, did you like move recently? I feel like I heard you say that somewhere. I hope that went well. I should do shout outs. To Matthew, who does coding stuff. Then Rez plays games. She's just an awesome person. Here you go, Jasu. Maine. Ooh. Hope you're enjoying it over there. I'm about to move up to Washington State from California, so that'll be fun.
Seattle, right?
Yeah.
Yeah, they say it's rainy.
Yeah, I went to visit in for a couple days, like last month, and it was rainy every day. And the New England supremacists. I feel like, you know, the coastal elites all feel that they're the best. It's been great getting adjusted. Just got to find work and all set. Nice. Now some rains here, lots in Maine as well. Nice change from the desert. I bet. um. How would we? Sorry that I'm off on a tangent, Hembox, but Anders, yeah, I got into the University of Washington for a master's in applied math. So I'm starting that in the fall. Yeah, thank you. And that's why I'm doing the complex analysis reading group, because there's a class that I have to take on applied complex analysis in the first quarter there, and it looks kind of scary. So I'm trying to study in advance. How do we apply the? I'm still trying to figure out how exactly we use this tau equals integral dt formula.
Yeah.
It's just whatever we got for gamma. I think it's it's really just gamma dt. What? Why did we get such a messy integral, though? And they don't. Complex analysis is so unreal, it doesn't even match here. They have 1 over.
Yeah, 1 over gamma, is it? It's on page 62. It was that section on time dilation where they talked about this.
Yes, I need to see.
Like equations 4:14 and 4:15. Yeah, the next page there. Yeah, you got it. Yeah, so what I tried in part C didn't work, I guess.
Did they just use the dx dt for v?
Maybe. And then
Dr. L,
C equals
yeah,
1, of course.
right. Hey, Desson. Dr. L, yeah, starting in the fall, I'm going to be going to the University of Washington for a master's in applied math. GT. Lucas, if you want to, yeah. It helps a lot if you take. I shot myself in the foot applying to grad schools because I avoided the difficult classes, and that looks really bad on grad school applications because I didn't think I wanted to go to grad school until the very end. So don't be afraid to take the classes that sound difficult if that's a goal of yours during your bachelor's. I'm not the first in my family. My dad has a master's in electrical engineering.
Cool. I think that's what my dad has too.
Oh, nice. I keep forgetting when I'm trying. Okay, yeah. Allegedly, we're doing integral root 1 minus g squared t squared over 1 plus g squared t squared. Does that clean up and get us the same thing as the problem? I feel like we already did this simplification
Yeah,
once.
you did that yeah, you did that already. You just didn't integrate it.
That does just turn into 1 over root 1 plus g squared t squared dt. Is that what the answer key has?
I think so.
It does. Dang.
So is this where they came up with that hyperbolic sign?
Yeah, I think it's just a definition thing. You could get the same integral with
Yeah.
ln's.
Okay.
1 over g. No, we're saying arc cinch. GT. Electra are the elite of engineers in the US. I haven't heard that, but I don't know. Applied math will be a blast. Took some applied math for mechanics. It's confusing because they set all the constants to 1. Why not trig sub? Because I'm lazy and rather use the answer key. So how does this affect our answer? What were we doing for part C?
So that's tau.
Oh, we're finding the relationship between T and tau. That's what we're doing. Uh, what were we doing with that though? I guess it's just the time component of position. Particle trajectory.
So it's funny, we still got X right.
Huh. Euler sub is better. Also, Markov probability test. Item G of a question is called a Markov Chebyshev or vice versa. Oh no. Doctor of Love. Skeleton is a math word? Ooh. That's so weird. I wonder if we got lucky with integrating dxct if we would have needed to multiply a gamma in or something. Or I don't know.
It was a particle moving in one dimension, right? It was just moving along the x-axis.
Yeah.
So maybe, yeah, so maybe it's got the same, I guess it makes sense that it traces out the same trajectory, right? Whether or not we're doing non-relativistic problem versus a relativistic problem. It kind of makes sense it would trace out the same trajectory. It's just that the time, if you're paying attention to relativity, then when the velocity gets big, we got to do the time conversion, right? I feel like that kind of makes sense. Why the x's would still be the same. The x function would look the same, but the time function would be rescaled because of relativity, maybe.
Yeah, maybe. Like I could see x maybe being contracted or something. Or like, maybe it's off by like a scalar multiple. But yeah, the path should be the same, like generally. There's a cat in physics that has published more. What?
Schrodinger's cat? Is that the cat?
Yeah, that is a cat in physics. I don't know that it published a paper. Okay, does that throw up our answer for part D? I don't think it does. We can call it a loss on C and keep on looking at the rest of the solution. Oh,
Yeah.
wait, there. What is this? Why are we completely wrong?
Free
What?
force is just mg.
So they're wow. So they used the answer from part C and took the derivative twice.
To get the acceleration.
Yeah.
Okay. All right. Well, I mean, that feels good.
Well, what we have is completely different, isn't it? um. What? Physics is 10 lines of computations that are all wrong. More like. I wonder what the issue is with what we did.
think we're not treating T properly. I don't
Evidently
think.
not. Huh.
Maybe you can only differentiate, position to get velocity and velocity to get acceleration when you're working with respect to proper time. Maybe that's the rule to keep in mind for relativity.
I think that must be it.
Because we had
Because
the
we
proper
got fooled
time.
by thinking that they're the same thing with what must have been
Yeah,
an
yeah,
erroneous calculation.
yeah, yeah.
Oh, Skeleton, the tilde is it means a four vector, a vector with four components, but like space time. It's not my favorite notation, but it's different from a regular three vector, so that's why we don't want to use the arrow again. Or it's different from like a normal Euclidean vector. Famished, if you want to redeem that again in like 20 or 30 minutes, I can do it. But for now, I'm going to refund you. I don't want to get more distracted than I already have. Okay, well, we did that half right. I think we get half points.
Sure.
Well, yeah, okay, we did A and B right. Okay, I think we got time for another. Um, you don't differentiate vectors from scalars? Oh no. That's kind of an applied one. Oh god. Frequency. Sorry, I'm debating if we want a momentum one or a frequency one.
There's a lot of problems in this chapter.
Yeah. Maybe let's try 12.
All right.
I'm kind of skipping around from the ones that I had chosen. Bring it in at the bottom here. Okay. 2 mile long Stanford linear accelerator accelerates electrons to an energy of 40 giga electron volts as measured in the frame of the accelerator. Idealize the acceleration mechanism as a constant electric field E along the accelerator and assume the equation of motion is that, where P is the spatial part of the relativistic momentum P. Complexes will be on Tuesdays, Desmond. Assuming that the electron starts from rest, find its position along the accelerator as a function of time in terms of its rest mass m, and F is defined as E times the magnitude of E. Okay, I read all that, but I didn't. I need to read it a few times before I actually understand the words. Uh, how about what's in focus? It's apparently the book that's going to get used for the class, so I need to check it to make sure they're going to use that for the next quarter. But yeah, so far it's not that good of a book. Assuming that one starts from rest, find its position along the accelerated function of time in terms of its rest mass. So really they're asking us to take this momentum, or I guess it's a force because it's dp dt, and find position.
Yeah. Well, that's a constant, right? E times E is constant.
Yeah, I'm a little confused why they're. I'm thinking of the differences between these two things here. They seem like basically the same thing. I don't know why they're phrasing them in different ways, though. I guess that's a scalar f, and that's the magnitude of a vector.
Okay. Yeah, makes sense.
But it's a one-dimensional vector for the purpose of this problem, I think. So why is this not just a Newtonian mechanics problem?
I think it's because the velocity is going to just be so high.
I mean, or maybe we need that for part B, but for part A, it seems like this is a constant. Let's just divide the mass over and integrate it twice. Uh, everything is a constant to you. Everything is a constant. Why can't I make an E? So, ta-da! This feels stupid, but I don't know what else it will possibly be. It's just a constant acceleration as far as I can tell.
Oh man, I don't think it works. I don't think that works like that.
But I don't know why not. We're doing it in the frame of the accelerator, I think. Is there some relation with momentum in something?
Yeah, page 87.
Right. Mass is a function of velocity. I have no clue at rotate, to be honest. Because they only give us the 3 vector. The 3 vector is the same though. Or like for the 4 vector, the space components are just the 3 vector.
Don't we have to find like proper time again?
Um,
Can we say dp/dt is m times v? Wait, is that right?
yeah, it's 3 vectors. I think we're okay.
No, it'd be m times dv/dt, wouldn't it? dp/dt would be m times dv/dt.
No, dx dt. The questions were getting a little bit crazy towards like the second half of the chapter.
Yeah, the 4 vector stuff, I didn't catch it. I didn't understand how it worked.
I don't know. I don't know what else like we could possibly do for A. I'm just gonna start thinking about B, but if I'm wrong about A, that's very likely. What electric field would be necessary to accelerate a particle to its final energy? Like that must be the one where we use that the time component of momentum for vector is energy. Or I guess we use E equals m squared plus p squared.
Yeah, okay.
Square rooted. Yeah, Dr. L, the Minkowski metric I think is what flat spacetime is called, like ds squared equals minus dt squared plus dx squared, yada yada. We want 40 GeV to be equal to nope. I think like that. But we should be able to know what T is, I think. Because by the time I assume T is gonna be whenever it gets to the end of the 2 mile long thing.
Yeah.
We can call it 3,200 meters. I'm gonna get confused with M's. Eigenlocked matrix? No, I've never heard of that. Oh, that doesn't have a clean split. No, yeah, that is this 80. Oh, we want T squared it anyway. Oh, no. Get rid of that. Get rid of that. It's a matrix that locks its eigens. It sure is. So we just get 6,400 M E E. It's all about me. M squared. No, just M. It's the 1/2. What am I solving for? I'm solving for E. I have no clue if it, I feel like this is the right process for part B at least, but I have no clue if we're working on a good foundation.
Is there any way to deal with this factor of M?
No clue. Syncop was saying I put in an extra EE. I'm not sure that I did. Because we have EE squared from up there, and then just one EE from down there. Because I don't see where... I don't see why that would be extra.
What about equation 546 from the book?
Hey, Deb. 546.
And they're saying that the P, what are they saying? energy momentum 4 vector. So the time component is m gamma, which is E, and the space component is m gamma velocity.
Mm-hmm. 5.47 is just like a rearrangement of 546 if you dot it with itself.
I think I got nothing on this one. I think I got nothing on this one.
All right, let's check the answer then. We're a little over time by now anyway. Um, Momentum P decreases linearly with time. How is that possible? Isn't it being accelerated? Oh, increases. Duh. Never mind. I thought it decreases. The more energy put into move, the more difficult it is to move further. Yeah, sorry, Jesse, I'm just illiterate. Yeah, Slim, I figured out a way that's easy enough for me. Oh, that's why they did the F thing, just to make it a bit cleaner with the constants. They find the 3 velocity by saying that 3 velocity is equal to momentum over energy. Huh. Well, you're right, Fembox. It wasn't as simple as I was making it. I would never have thought to do this.
Nope, me either.
I thought to use the right equation for part B at least.
Yeah. So there was a way to get the mass out of there.
I guess it canceled at some point. Okay, well, I mean, that was how this question is how I was expecting the entire day to go, to be fair. So we at least had half of a good day.
Yeah, we started out pretty well.
Hey, Gold. We sure did. We just did
we got like
this problem completely
one
wrong.
and a half question.
Yeah.
Not bad.
Okay. Where do we go from here? We can do another week on chapter 5, or we can push forward. The thing is, the ones from chapter 5 are either very difficult or very weird, and I kind of just want to push past it.
Yeah. Yeah, okay, let's do that, because
There's a
Just
lot of
hoping
like
that.
complex ones. But yeah, so I don't know, if you don't mind, we can try to go over chapter 6 next time.
Yeah, why don't we do that?
I read it up to 6.3, I think, not
Oh,
including
how is it?
6.3, and it's very light on the math. It's been pretty much all conceptual so far, which is nice.
Yeah, I'm flipping through it. It looks like just more reading, less formulas.
Oh, I think I've even read through chapter 6.3 now, or most of it. But yeah, I think this one is going to be a relatively lighter chapter, I think. I hope.
All right.
Oh, that. Okay, I just. 6.20 might be the most disgusting formula I've seen so far, but aside from that. They go back to doing c not equal to 1 partway through, and that's kind of annoying.
Oh, yep.
But yeah, it can get way more disgusting, Gold says. Oh, good. It's great to hear.
All right. I'm
Okay.
I'm holding on for grim death.
Yeah, this is all just for fun. So if we just want, if we crap out at some point, it's not like anything happens. So, all
Yeah.
right. Well, thanks for being here,
Yeah, yeah.
and I'll talk to you next time, I guess.
All right, Don. Yep. We'll talk to you then.
All right. Bye. All right. Another reading group down. Let me okay, first things first, let's get some music going so the silence isn't deafening. Uh what playlist are we using? Where are we dropping? Maybe we'll do this playlist. Can't think of a better way to spend your Saturday afternoon than being inside and learning physics. Um Actually, before I do the Discord announcement, let me switch over my title and category and stuff. Answering math questions from chat and internet. We got a question from Lucas we got to look at. Math. All right, let me switch my YouTube info. It's not really that much of a point in hiding this, I guess, but I already hit it, so. Okay, that's switched over. YouTube chat is here. They just haven't said anything in a bit. Uh, that that's YouTube chat there, like right there. Yeah, see, Papadori said hi. Um, Notes for chapter 5, part 2. Nope, that's not it. Sounds good, Synculp. Okay. Cool. Yeah, I had the I have a different description in the YouTube um, for uh, the reading group versus the math help, and so that was the description I had copied. Chains and whips lead to excited states. um, honestly, YouTube doesn't have nearly as much of the math. I mean, it does have a math community, just not the same as we have here on Twitch. Yeah, exactly. As Gold says, like there's some rares who come by the YouTube chat, like Papadoria, Mert, Sandkalpa's in there, Teratar. But yeah, YouTube people you just like kind of get in and out. In vertical short forms, no, I never really have taken that idea seriously. I personally really don't like TikTok and would never use it for myself, so I have an aversion to streaming on it. Posting shorts is a good idea that I just should do, but kind of don't. And yeah, this is Dutch. 10K views on a YouTube short or a TikTok? Holy crap. Gotta close out a bunch of these tabs. I have way too many open. YT Shorts. Oh, you can stream a YouTube. Like, you can stream to YouTube in vertical format? I just do it in regular. I didn't know that was even an option. Huh. I bet I could do both. I wonder if I could do both, actually. I don't know. In the short speed. Wow. That might be... that's something to look into then. Um, Atrium. That sounds familiar. Bob. Hope you're doing well, dude. Um, it's either in English and impossibly difficult, or it's not in English. So take your pick, Bob. Yeah, I just use a general like multi-streaming plugin in my OBS right now, and I assume you can't stream to the same channel, two different formats though. I don't know. I have to figure that out. You just got mentally smashed. Me too. You can? Oh, okay. Doesn't sound like there's going to be a harm in that then. You do vertical and horizontal. Okay. Different stream keys. That makes sense. Yeah, I bet I have another thing to like hit start on, but that'd be fine. Tell about a case that lines L and M. Yeah, sorry, I've I had the question up, but I haven't actually been reading it. So are these are three-dimensional lines? Is that what's happening here? Cut each other, parallel, cross, intersect. Skew. Yeah, I'm gonna plug this baby into Google Translate, I think. Unable to paste. Hey, there we go. Okay, well that's actually not a lot helpful. It is always cool that Google Translate can actually do that. Um, let me read what you actually like. Yes. And M. It's this language. It's Dutch. So A is intersect. Are parallel. And then I think is skew, as in they don't intersect, but they have different slopes, is how I'm interpreting part C. Oh yeah, Hamish, with the time that I normally stream at, uh, there's quite a few Europeans who are able to watch. And also, I really like seeing how other countries do math. Grim, you have your JE advanced test today? Oh my god, good luck, dude. Godspeed. Um, I mean, whenever you get some tough like JE advanced question, Crim has pretty often jumped in and saved the day for us. How the hell do we do this? What type of line does this define? Or like, I haven't seen a like this is a three-dimensional line. I'm not used to having them in this format though. Um, I need to figure out how the hell this works. Yeah, seeing like we can get y equal to z in some way, shape, or form. Isn't this more like a plane? Is it supposed to be a plane? No? First line in terms of x, second in terms of z. Yeah, if I just let x equals t, I think I want to see this parametrically. X equals t. Y is minus a half minus a half t. Z, this is a line. Is k minus t. That looks clearly like a line to me. Now, one linear equation in terms of plane, two linear equations of line. Oh my god! These are like vectors, right? Or wait, no, this is like the opposite of vectors. Or no, yeah, yes. Wait, I have to do the vector interpretation now. It's like a rank 1 versus rank 2 thing, right? If you just have one, if you just have rank 1, that defines a line, but then no, I have the slight, I know there's interpretation there. I have it slightly backwards though. Like the null space is a plane. That's where I'm getting confused. If it's rank 2, the column space is a plane. I mean, I'm confused with whether we want column space or null space, I guess. But yeah, these are like the general. We can make a vector out of this. Okay. Co-rank n minus rank. Oh, crank? C rank? Co-rank. Columns minus rank. Oh, is that like what I would have learned as the left null space? N minus R. Maybe that's no. I don't remember. I get write them as major C's if they're not equal to 0. Translate the line slash plane. Yeah, I don't know. I'm sure there's an interpretation like that. It's not necessary for like the what Lucas is doing when he's asking this question, but yeah, that's where I'm getting confused. It's basically what Jasu was saying, where one vector can just determine a line, but in R3, the null space is going to be a plane. So I guess this is the normal? Or I guess the left null space, rather. A line can determine a family of planes, I guess, that are offset by a constant. I don't know. I don't know what the most efficient way to do this question is. I hope I just need to play around with this, I guess. Just force X to be T and then let the chips fall where they may. Minus 2 minus X over K. T. Can always move these lines to the vicinity of a black hole and do funny GR stuff. Someone can, Apertay. I sure as hell can't. We haven't even gotten to any actual general relativity yet. We were only on special relativity, and we're still struggling. Saying up is saying Kramer's rule? Maybe. Not sure. Maybe. I'm not sure either. Okay, I should... There's a helpful rewriting of Y here to make it look more like the L. In the shape of an L on her forehead. So in order for these to be parallel, what needs to be true? The coefficients of t should all be equal, right? That's the condition that we want. And I think k equals 1 gives us that. Oh, I'm thinking about part B for some reason right now, but proportional, not necessarily equal. Oh. Yeah, I guess we'd need to factor stuff out. maybe what you're saying. No, wait. Yeah, for part A, we just need them to be equal. Um, for some reason that I'm finding that harder though. Slopa. Yeah, but like the way we think of slopes here is the coefficients of t. Like that's the part that's confusing me. I think that's what you would do. We could Desmos this as well. I'd like to try it by hand for a bit more though. Uh, so in intersection, could we do the stupid thing would be to have four equations and four unknowns and solve it that way, right? Is there a more clever way we can do this? K is equals -1 gives an intersection. Is that guess and check? Maybe we want to mess with these two equations and try and get rid of x and z somehow. Maybe we don't need to fully solve the system, we just need k. Z. Now can I get rid of z? I'm gonna go around in circles if I do. Uh, it's annoying. I've already used up the bottom two equations. If I involve either of the top two, I can't uniquely solve for z. I would love for there to be a way to just eyeball this. What happens if I add all the equations, or if I add each of the equations with the other one? Wait. In solve your system, you have to use T1 versus T2. I mean, I was hoping to avoid the T's for the intersection part. I'm assuming the T's aren't a good thing. This right here is 2 equations, 3 unknowns. That's the issue. What have I done when I add these together? Like I added those 2 together to get that. Because that looks like a plane now. I took a linear combination of 2 vectors maybe and I got a plane. I don't know. Does this do anything for us though? Is this a good thing? I don't know. Desmos time? It could be. Pemok's pointing out like these should be different T's. I think that's a good point. Mirza, you can type it out right there in chat, or if it's easier, you can put it in my Discord. So if I do try to solve it with the parametric equations, we need each of the individual components to be equal to each other some ways, somehow. So T1 has to equal T2 from the X's. From the Y's, and that should be a thing. From the Z's, that should be a thing. And so we can eliminate, T2 if we want. I'm going to multiply. No, I'm not going to multiply anything. So that's 2 equations, 2 unknowns. Which is maybe what Jasu was also advocating for. They're not linear, which is a little bit annoying. They also just look stupid, which is even more annoying. Multiply that one through by 2k. Minus k minus kt1 equals minus 2 minus t1. Multiply that one through by k. k squared minus kt1 is minus 2 minus t1. Okay. We want to solve this for k. So solve one of these bad boys for t, plug it into the other. So if I take the first one, minus k, there's so many minus signs in these equations. Yeah, Dr. L. Is that right? From this equation. What am I doing? Added the minus 2 over, added that. Okay. So t1 is minus k plus 2 over k minus 1. Plug it into the second equation. K squared minus k plus 2 over k minus 1 minus 2 minus k plus 2 k minus 1. Okay. Well, this is a cubic, and that makes me feel bad. Suna! Thank you so much for the raid. I hope your studying was good. I hope your Sea of Thieves was good. Anything else that you were working on? For anyone who's new here, I'm Don. I do math help streams. We're working on this very tricky question that is in Dutch up here. Basically, we're given two lines that have this constant k involved, and we have to find values of k that make them intersect, make them parallel, and make them skew. And yeah, I'm a little bit rusty on this. Hello, Suna. For anyone who's here on my end, Suna is a cool person, does studying, does video games, all that good stuff. Hey, Poison Mouse. Subtract those two equations and solve pretty quickly. There's at least 15 equations on the screen. I don't know which one you mean or which ones you mean. These two? Oh, bro. Thank you. Bruh. I should say, not bro, but bruh. You're right. Just subtract those two. Minus k squared. Is that 0? Yeah. Okay, thank you. The hard O? Yeah. I know, bruh is more fun to me than bro. I don't know why. Okay, so k is 0 or minus 1. I assume k equals 0 is boring for some way. No, it's not serious. This is just three-dimensional space and lines in 3 dimensions. Okay, so presumably either one of the things that I got would work. You know, you could express these as series. They wouldn't be very interesting series, but you know, you could. This is Lucas. He said this is a 6th year's question, which I don't know if that means 6th grade which would be crazy for a 6th grade to be able to do this, or if that means something else in the Netherlands. But I don't think it's supposed to be it's not supposed to use very complicated math. It's not simple to do, but we shouldn't need any tools that are too crazy. But year 5, like Lucas is like, in American terms, Lucas is somewhere in high school, as far as I know. And so I don't know what year 5 correlates with. 6th grade in Korea? Probably, yeah. Or maybe it is just 5th grade and I've been wrong about Lucas. I don't know. Lucas is doing some crazy math. If that's 5th grade. Last year of European high school. Okay, that makes sense then. It's like Lucas has done like epsilon delta proofs and stuff. I want to verify this in Desmos. I think it's Desmos time to check the intersection stuff. We haven't done the other parts of the question. We've theoretically done the first part. I'm going to use, I guess, my parametric equations. T minus a half t k minus t. T is going to go from minus 100 to 100. God, Desmos is so powerful, dude. T minus 1 over k minus 1 over 2kt. Oh, one more component. 2 over k minus 1 over k t. 0, 1. No, 100. Minus 100. Okay. So I said k is 0 or minus 1 for intersection. I think we're seeing a parallel case right here. K equals 0. Is that the same line? Is that what you're... I can't tell. Or if I'm just zoomed out wrong. It seemed like the same line, which I feel like should be more obvious than it is. Oh, we found a perpendicular case. Hey, look at that. K equals 0. Oh, you're right. K equals 0 is undefined. Thank you. Math Academy, welcome in. You can type them there in the Twitch chat, or you can put them in the Discord. Whatever is easier. I can divide by 0, Jasu. I just don't want to tell anyone how. It's a secret. Okay, so yeah, we do need to throw a k equals 0 because I'm not willing to reveal my secrets. So -1. Oh, sorry, no, perpendicular wasn't a thing for C. So for part A, k equals -1. Just between you and me. I'll send you a message, Suna. Okay, so k equals -1 is good. Parallel, we know the answer by accident. We should do it the right way. What is the right way? Oh yeah, we're thinking about the slopes, right? Or the coefficients. Oh yeah, it just kind of makes sense. Like, coefficient 1 1. Coefficient minus a half. That's already minus a half k. Minus 1, minus 1 over k. So k equals 1. It actually is kind of clear to me, at least from the parameterization, that k equals 1 gives us parallel. Represented as vectors, prove they are perpendicular. We can definitely represent these as vectors. We can definitely do that for... We don't actually need to show... They're not asking us to show perpendicular for any of this. I'd be interested to see the linear algebra way for this in general. But, what am I trying to say? If we needed perpendicular, we'd absolutely need a dot product here. But we don't have to, so I don't think we need to. Yeah, Skew is not intersecting. Which I guess is everything else. Not intersecting and not parallel. So, yeah, since the parallel case, or sorry, the intersection case was so particular, k had to be -1. Well, k equals 0 is a valid answer. Not with my parameterization. Oh, maybe it's not. It's not good in my parameterization, but k equals 0 could still be true. We'd have to check that. Or I might have, yeah. But yeah, Lucas, I'm kind of struggling with this question. I'm not that experienced with this type of question, to be honest. But I do not feel sure of myself. I think you can safely say like k equals 2 or anything that's not 0, 1, or -1. Let's check it. Because it should be that most cases are skew, right? That should be the most common thing for two lines selected randomly. Yeah, so k equals 2 works. Nobody in class could do any question. I mean, if it's for next year, that's kind of understandable. Okay, but I think we figured it out now. If you want me to explain it to you from the start, I'm happy to do that. Let me know. If you were just kind of seeing the process, then there you have it. But just kind of joining wonder how hard the next class is going to be. There might be a more convenient way of doing it than what I did here. I don't think the math involved is going to be that bad. I'm just not very practiced with these types of 3D problems. But if I was in practice, I think this would be a lot quicker of a question. There was another question that was posted to the Discord. Ooh, it's complex variables. Just in time. This is Math Academy or Mirza's question, I think. Realty News punch drunkenness is wearing off. Good, good. Okay. It feels a little bit weird, but we can do it. So for the first part, they want us to prove something about the modulus of z squared being equal to z times z conjugate. So first off, let's establish what the modulus of z squared is. By definition, the modulus of z is the square root of a squared plus b squared. I should write this a little more neatly. And we have a squared outside, so the square root and the squared go away, so it's just a squared plus b squared. Now let's start from the other end of the equation, z times z conjugate, and see what pops out. We're going to hope for this. So z is a plus ib, z conjugate is a minus ib. So let's multiply this out. We get a squared minus iab plus iab minus I squared b squared. These two terms in the middle cancel. We get an a squared. I squared is -1, so that minus flips to plus. So plus b squared. Therefore, these two things match, so they're equal. That's the first part. The second part is that. So let's work on that now. That should be a little shorter, I think. Z minus ki star. Well, let's start with the same first step. Complex that can't be real. This question is so math that they use I and not J. Oh yeah, I forget what context they use J for the imaginary number in, but I'm not a fan. I was thinking of creating a game where a radioactive asteroid hit the Earth. What's left of the world is radiated. As soon as you step outside, you die. Humans have to live underground. Ooh, that sounds like my type of game. It sounds like Fallout, but an asteroid instead of a nuke. Oh, like Gaussian elimination, Matthew. I think it's probably Gauss pivot. Or like row reductions, you might say. Anyway, z is a plus ib minus ki star. And now, let's factor the I out from those two terms. So we get b minus k star. There's a more general version of this that you can prove that's better, but we can do this. And now this looks like just a normal complex number. And there's a real part and an imaginary part. So just negate the imaginary part. But the thing we want is z star plus ki, so we need to fiddle with this. So let's multiply the I back in now that we've conjugated. Plus ik. And look, a minus ib, that is z star. So let's plug that back in. Plus ik, and that's what was desired. Electrical engineers, because I is amps, that's right. Are you studying electrical engineering? I assume this is the process they want us to use, Poison Mouse. I could definitely have done this way quicker. Just by... I assume the person who's doing the question doesn't have this property here. I was trying to avoid using that that property. That's why I was doing this weird thing. But you're right. From the start, if we didn't know this, we could have done a lot quicker. Okay, Argand diagram. Okay, this is gonna be a thing. Modulus z minus 10i. It's in mechanical engineering. It's one name in your country. You have your third coffee of the day. Oh my god. Good luck. Minus 2 or equals 2. If you're doing electrical engineering, I would have recommended a streamer to you. Mechanical, though, I don't know of a mechanical engineer. Okay, they want us to square each side and end up with that. Let's just square each side and hope and pray. Four z minus 4i. Oh, we're gonna need to use a property here in a second. Okay, so we're gonna use the two properties from part 1 because we have a modulus squared. So let's make it a z times z conjugate. But in this case, we don't have just z, it's z minus 10i. So this thing modulus squared is z minus 10i times z minus 10i conjugate. But we can use property, maybe I'll do it in the second step. Let's just do one property at a time here. Okay, now we can use this property to get rid of the conjugates. Four to the inside. I don't think I'm trying to avoid doing that as long as we can. Hey, Nevin. And I assume now we just multiply everything out and get everything onto one side. And hopefully we end up with the same result. So multiplying on the left-hand side, z conjugate plus 10 zi minus 10 z conjugate I plus 100, because 10 times 10 is 100. There's a negative and there's an I squared. Now we get 4z conjugate plus 16zi brain lag minus 16z conjugate I need like the dial-up sounds when I have like brain lag like that. 64 4 cubed. Subtract everything over to one side. I guess I'm going to bring left to right. Then we can divide through by 3. I was worried that I wasn't getting the 1 coefficient, but I'm glad we got a common factor here. Does that match? Yeah, looks like it does. Okay, good. So we got the first part of number 2. Now we need to go down to that part. Yeah, it would be poison mouse. Sure, the magnitude of z minus 2i is 4. A. Probably have to factor this in some way. Is it a perfect square? Or it's a z times a z conjugate? What is z minus 2i times the conjugate? This is what we need to compare our equation with. Okay. So this is the same idea as completing the square, except it's like we're completing the modulus square, which involves a conjugate. So it's not quite a square. But I see we want a 4 here, a plus 4. There's a minus 12 there. We got to do a plus 4 minus 4 thing. And once we do that, we can say z minus 2i conjugate minus 4 minus 12 is minus 16 is equal to that. That's the key idea here. So, oh, that's cool. I didn't know you could do that. I did that by accident, turning that text into green. This text in green is just side work. To figure out how to deal with it. And now we have the exact thing that we want because we add the 16 to the other side and we say it's equal to, we're using this property in reverse now. Z minus 2i modulus squared, and then you square root each side. And you're home free. It's advanced as hell. It's not easy to put together, but we're not doing it like anything conceptually crazy, I don't think. Oh, well, math, never mind, okay. Oh, sorry, I didn't see you were talking to Matthew before. Vector spaces when Euler-Totient stuff in high school. Wow. Yeah, that's crazy. I do hear that Europe emphasizes algebra way more than America does in general. But that's still super early. It's good though. Europe does more calculus than Americans. That would surprise me. We do a lot of calculus here. I don't know how much calculus you guys do over there though. Okay, now for part 3, describing it geometrically, this is where I'm going to fall short. First question. What exactly is an Argand diagram? Is that just the region of complex numbers that are satisfied by that equation? Or is it something different? Okay, I think it is that. Friends that did school in America told you could follow a course in university while at high school. Technically, you could do groups. Uh, it depends on the high school for what they offer. At my high school, we only had calculus as the university level courses that were offered to us in stats, like statistics. That's all. It's called AP, that system for advanced placement, and some high schools do offer IB, International Baccalaureate, which I think is also in Europe. That, for all I know, can include algebra. I don't know, but yeah, I would not have had the opportunity to learn algebra while I was in high school, personally. I'm concerned that we started by squaring each side, though, Fembox. That's what I don't get. I definitely agree this is a circle. But is this the same thing as this? Yeah, I agree with that. But like this question seems pretty scaffolded, so that this observation should help us somehow. Oh, hmm. I just noticed that that is nearly that. I mean, what is this saying? The distance from Z in 10i is equal to twice the distance with Z in 4i. There should be some simple cases we can work out. K equals 1 would be a line? Would it? If I'm working on the imaginary axis, there should be 2 points on the imaginary axis that satisfy this equality. Hey, Evertons. Totally understand this? Hell yeah. Unless you're being, oh, you're being sarcastic. Okay. Um, Not a clue. Actually, I mean, we could test it. Maybe doing the other thing. Maybe let's assume this is right and then test it later. Reload. We're on part 3. The only thing we're confused on right now is if this is the same thing as this because we squared each side. Apollonius Circle? I don't know what that is. One big old boob. That's a set of points that we get. A squared b squared is c squared. That looks a little too boob-like. I'm sorry, guys. I'm gonna take away the nipple. Wait, so this is a circle. I don't know if this is the same thing as this. That's the issue. So what it is, I just drew this, and I want to test if every point in this also satisfies the original. Academy? If only. Um, so what am I getting? Minus 2i is a point? That seems true. Positive 6i is a point. That seems true. Uh, Maybe these are the same. A and B are fixed complex numbers, k is a positive real constant. Oh, this has a name? Sneaky Tomato, welcome in. That's the type of math that you can expect around here. We don't like math that's correct. We like math that makes us feel good. That's really the most important thing. Let's equals x plus iy for both. You get the same circle. Really? I guess that's what they're doing here in saving us the pain. So wait, it's not the same exact circle though, is it? Oh yeah, that's true. A equals B equals 0 for that. If either of them are 0, I think you're good. The other one could be anything. Um, so they're finding here, it's not the, or is it? What are they finding? Okay, I think it is just this circle. It would make sense if it's just a 1 mark question as well. A circle centered at 2i of radius 4. Wait, is it radius 4 or radius 2? Yeah, it should be 2, right? I did that wrong. Reload is saying radius 4? Oh. Okay, it's radius 4. Our steps seemed reversible. Write your steps in reverse when you point the circle also has the original equation. Square's taken only of non-negative. Oh, Lubert. Okay. Yeah, I guess it's a squaring that I was really concerned about there. But yeah, I guess you make a good point. Huh. Okay, so I think to person asked the question, I think that's just the answer right there. It's a circle of radius 4 centered at 2i for the last part. If you have questions about anything that we've done here, let me know. I think I feel like I just need to see this z equals x plus iy thing. And I'm just gonna do that for my own education here. Because it just I feel like I just need to see it for some reason. No worries, Mirza. That's who it was. Thank you for the question. Okay. I shouldn't do that much mental math in my head. I was gonna multiply all of these out and subtract everything over to one side in my head, but that's way too ambitious. There's no way in hell I can actually do that not mess something up. G Hive, how's it going? It's good to see you. 16 minus 32. Do what? It is a nice prelude problem for Tuesday. Factor 4 on the right-hand side, BJFR says. Where? I don't see where. I'm going to subtract things over to the other side, though. Bruh. Second line. A 4? I don't see a 4 there. So I ended up playing Rust for the first time? Ooh, how'd it go? I imagine you need to put a lot of time in that game where you can really have a good opinion. Third. No worries. I still... A 4 on the right hand side? Like, there's that 4 there, but then there's a 2 there, but... I'm not picking up what you're putting down. Poison Mouse is saying... C equals 10 I minus 4 times 4 over 1 minute. I don't know where that's coming from, Poison Mouse. Plus y squared, not minus? Ooh, thank you, Femlux. I'm already nearly there with this method. If there's a more efficient way, then fair. Oh, this isn't good though. I'm getting something. Mirza saying make perfect squares, right? We have to do that. Naman, I'm always back here. Today must be JE. So Krim was saying he has the JE. Golden, hey, good luck with your big exam. PvE to try it. It's weird, not DayZ. Yeah, I played a lot of Ark Survival Evolved. Which is like apparently a similar game, and that I love the theme of it, but the devs really let that game down. So I never had any interest in Rust. I'm getting the right center here. Oh right, that formula Poison Mouse they said in the Stack Exchange thread. I just wanted to see it this way for myself. I'm getting the wrong radius though. That's the issue. I flipped a sign on that 68, I think. Or I flipped some sign somewhere. Or I messed this up, the minus 16. Is that what I messed up? Oh. I think it should be a 32. Is that what I did wrong? $16. Oh, good luck with your A levels, Mirza. Coefficient is 4, not 2, in the third line. This coefficient? I think that's just a 2. So that's what BJFR was saying that's 2 squared. I don't think it is, though. I think it's just a 2. I'm not squaring each side. I took the magnitude of this complex number. I took the magnitude of this complex number. I did not square anything. Ah! That's what I meant. That doesn't work. Thank you. Okay, BJFR, I owe you like 3 apologies. So I'm sorry. You're right. Okay, well now I'll just do the calculation I was doing before. It's 4 factorial. I didn't think that I squared anything, but I implicitly did square something and didn't realize it. All right, see you, Poison Mouse. Thanks for hanging out. Okay. I think from here I can just believe that we're going to get a circle. Because now it's basically, I feel like it's the same calculation that we just did up here. Too busy horse riding. That's right. Jasu is a horse girl. Wait, you can simulate poverty? Or like the UN simulates poverty? I've never heard of that. As a vacation? Yeah. No, I was just catching up with chat. I saw that Matthew said that UN has vacation camps where you can simulate poverty. I I guess it's supposed to be an educational experience. It doesn't sound like much of a vacation. Show jumping? Oh, of horses. I thought like you use a person just jumped in a cool way. First person trying to be down to earth. Yeah, I mean it kind of does, even without the JKs. For kids, all sorts of simulations. Huh. Fair enough. Okay. Oh. Okay, no. Mirza. Oh no. Mirza posted the marking scheme. I really hope there's a typo in it. I'll show you all why. So I really hope that 5 is an error. I could Fembox. My voice is dying though, so I'm probably not gonna stream for much longer though. CIE? What is CIE? Why is it 5? I I'm concerned. Now I want to go back to doing this and find what the radius is. I assume that has to be an error. There's no way it's gonna be randomly 5. And yes, yelling when I realized I did this part of the question wrong did not help my voice. I really shouldn't have done that. You got this, Mirza. Minus 32y. The 44 feels wrong. Thought it was Tuesday. This is a complex variables question. Now, I agree 44 is a sucky number, and I don't like it. Oh wait, this is 32. You're saying. Oh, yeah, I don't know. I did that wrong. Is this still okay? 4 cubed? Yeah, I think that's okay. Daddy horse issues? Oh my god. First, Mirza, you got this. Reload, you got your first further math exam on Tuesday. Thought it was tweaking. 12 then. We can divide out the 3s. My internet's getting worse and worse. Okay. I think it's an error in the answer key. I feel like it has to be. It's gonna haunt me. Can Wolfram Alpha solve this? I want Wolfram Alpha to solve this. I don't like the answer key says 5. Our Lord and Savior, Wolfram Alpha, will be the judge of this. Assuming it can do this, I hope it can. I assume that's a. I assume that's what we want. I'm not gonna bother checking it, but I think the answer key is wrong, like you all are saying. Um. How crazy is she? Okay, crisis averted. I think. Thank you for the question, Mirza. I think we're probably gonna wrap things up here for the day. Because my voice is feeling it. It's telling me it's time. So yeah, on Tuesday we're gonna be doing the complex variables reading group. I'm sorry, my stream an hour later than usual for that. Actually, I need to remember. Yeah. Go to the scene, and then people on YouTube, thank you for being here. We'll be back on Tuesday. On Twitch, we'll look for a raid. And I'll see you later, YouTube.